Princeton scientists have made a remarkable discovery while examining fragments of a meteorite that fell on Earth 15,000 years ago. They found a rare mineral called khatyrkite, which was composed of a crystalline structure that appeared to defy the laws of earthly physics. This discovery raised the question of whether these structures were from outer space rather than being of terrestrial origin. One scientist involved in the study, Paul Steinhardt, a professor at Princeton University, embarked on a detective-like investigation to determine the nature of the quasi-crystals found in the meteorite. Steinhardt and his colleague Luca Bindi sent a sample of khatyrkite, the only known sample at the time, to geologist Lincoln Hollister at Princeton for analysis. Initially, Hollister suspected that the quasi-crystals were a result of an industrial process on Earth, but further study led him, Bindi, and Steinhardt to conclude that the structure could not have been man-made. One contributing factor was the presence of stichovite, a rare version of silicon dioxide, within the meteorite. Hollister stated that stichovite was not something produced on Earth's surface, leading Steinhardt to realize that the quasi-crystals had formed naturally. The story of quasi-crystals began with Daniel Shechtman, an Israeli scientist working at Maryland's U.S. National Institute of Standards and Technology in the early 1980s. Shechtman made a surprising discovery while studying a manganese and aluminum alloy. He observed a crystalline pattern unlike anything seen before. Unlike traditional crystal structures with repeated symmetrical patterns, Shechtman found a cluster in which each shape was different. This discovery challenged the accepted understanding of crystal structures, leading to skepticism and ridicule from some scientists. However, Shechtman's findings eventually earned him the Nobel Prize in Chemistry in 2011. Quasi-crystals, despite initially being considered too volatile for natural formation, were found in the khatyrkite sample analyzed by Steinhardt and Bindi. This challenged the prevailing belief and raised the possibility of quasi-crystals naturally occurring. Steinhardt sent a fragment of the khatyrkite to the California Institute of Technology, where scientists discovered oxygen isotopes indicating its extraterrestrial origin. The quasi-crystals had formed naturally, but not on Earth. Their creation dated back over 4 billion years, coinciding with the formation of our Sun. To determine the origin of the khatyrkite, Steinhardt investigated its path to the Florence Museum of Natural History in Italy. He found a promising lead when he discovered a letter in the museum's records suggesting that the box containing the sample had come from Amsterdam, Netherlands. This discovery prompted further investigation into the meteorite's journey. In conclusion, scientists at Princeton made a groundbreaking discovery when they found quasi-crystals in a meteorite sample. The presence of these rare and seemingly otherworldly structures challenged the prevailing understanding of crystal structures. Through meticulous analysis and investigation, they determined that the quasi-crystals had formed naturally and originated from outside Earth, shedding light on their formation over 4 billion years ago. In the city, there was a collector named Nicholas Kokik who had sold a mysterious meteorite sample to the museum. However, despite searching extensively, there was no record of this particular meteorite in Holland. A stroke of luck occurred when Steinhardt's colleague, Bindi, attended a dinner party in Florence. During the dinner, Bindi shared the story of the enigmatic khatyrkite meteorite sample and the elusive Kokik. Surprisingly, one of the guests mentioned knowing an elderly woman named Kokik who lived on the same street in Amsterdam. Upon returning to Amsterdam, Bindi approached Mrs. Kokik and inquired about a collector with the same surname. To their amazement, Mrs. Kokik confirmed that her late husband, Nicholas Kokik, was indeed the collector. Excited by this revelation, Bindi immediately flew from Florence to Amsterdam. Mrs. Kokik, though unaware of the boxed khatyrkite fragment, granted Bindi access to her late husband's papers. In her spouse's secret diary, Bindi stumbled upon an intriguing entry. It revealed that Kokik had purchased the sample from a person named Tim in Romania. However, despite the promising lead, their attempts to locate Tim proved futile. Undeterred, Steinhardt sent Bindi back to Mrs. Kokik to inquire further. Although she didn't know anything about Tim, She disclosed that her husband used to maintain a secret diary. This diary proved to be more informative, as it unveiled that Kokik had actually acquired the khatyrkite sample from Leonard Raisin at the Trush's Institute of Platinum in St. Petersburg. Steinhardt recognized Raisin's name, as he had announced the first discovery of khatyrkite in the 1980s. Kokik had subsequently sold the sample to the Florence Museum, while another specimen was housed in a St. Petersburg attraction. With this new information, Steinhardt sought out Raisin to gather more details. Unfortunately, Raisin couldn't provide an exact location for the find. All that was known was that the sample had been discovered in the Koryak Mountains, a vast mountain range in Siberia. This limited information posed a challenge. However, Steinhardt decided to revisit Raisin's 1985 report on khatyrkite, hoping for a breakthrough. The report mentioned Valery Kryashko, who had been involved in the finding. In a stroke of luck, Steinhardt came across a 1995 study co-authored by Kryashko. The physicist felt a glimmer of hope as they went from having no leads to considering Kryashko as a potential key figure. Steinhardt managed to track down Kryashko, now in his 60s and living in Moscow, Russia. Despite the language barrier, they used Google Translate to communicate, and Kryashko willingly shared what he knew. It turned out that Kryashko, as a graduate student, had been employed by Raisin in the late 1970s to search for platinum. Kryashko had traveled by helicopter to a remote location in Siberia, where the nearest settlement was hundreds of miles away. There, by the Lizvinetavi stream in the Berengovsky region of the Koryak Mountains, Kryashko had worked with heavy clay in his quest for platinum. Although he didn't find any precious metal, he stumbled upon some peculiar metallic lumps. Kryashko handed these intriguing substances to Raisin and had no further knowledge of their fate until contacted by Steinhardt and Bindi years later. Fortunately, Kryashko was able to pinpoint the exact location where he found the khatyrkite. This region in Siberia was so far east that it was humorously noted one could see Sarah Palin from there. Additionally, the area experiences a brief thawing period for only a few weeks each year, providing a narrow window for exploration. Despite the challenges, Steinhardt, Bindi, and a team of 13 individuals, including Kryashko, embarked on a 4-day journey across the tundra and snowcats from the mining settlement of Ameder to reach the Lizvinetavi stream. They set up a temporary lab at the location, analyzing samples and excavating the clay with its distinct blue-green hue. The team encountered harsh conditions and even had to be cautious of bears, stationing someone with a machine gun as protection. Their efforts proved fruitful on the first day of excavation, when Bindi spotted a rock fragment among the clay that appeared to be a meteorite fragment. Over the course of more than a week, the scientists sifted through 1.5 tons of clay, yielding a few pounds of potential samples. After completing their work, they returned home, narrowly escaping the onset of winter. Back at Princeton, Hollister and his team analyzed the samples, which included 9 grains identified as meteorite fragments. Notably, these fragments contained rare copper and aluminum alloys, as well as naturally occurring quasi-crystals. The researchers spent an additional 2 years studying the composition of the khatyrkite and formulating theories about its creation. According to their findings, the khatyrkite mixture, including the quasi-crystals, was likely formed through a massive collision between 2 asteroids. Additionally, the rare materials found in the khatyrkite were thought to have originated from unknown processes in the solar nebula, the cloud of space dust and debris that formed our sun and the planets. Another possibility is that the unique constituents, including the quasi-crystals, were formed due to the force of violent asteroid collisions. However, the scientists acknowledge that they still have much to learn about the natural formation of quasi-crystals. Steinhardt emphasized the early stage of such studies in 2016, acknowledging the need for further research. Thank you for watching, and don't forget to like and subscribe.